Look at these three numbers a person earns. 8,000, 8,500, 9,000. Now these, 45, 43, 41, and these, 100, 150, 200. Every one of them is hiding the same idea. You keep adding one fixed number over and over. Master that one idea, and you can predict the 100th term without writing the first 99. That's what this chapter is about. Let's build it. Watch what happens between the terms. In the salary list, we add 500 each step. In the ladder, 45, 43, 41, we add -2, so the rungs get shorter. In the money box, we add 50. The number we add is different from list to list, but within one list, it never changes. That fixed jump is the whole heartbeat of the pattern. Quick vocabulary. Each number in a list is called a term. We label them A1, A2, A3, and so on. A1 is the first term, A2 the second. Here's the definition. An arithmetic progression, AP for short, is a list of numbers where each term is obtained by adding a fixed number to the term before it. The only exception is the very first term, because nothing comes before it. That fixed number has a name, the common difference written as D. And here's the part students forget. D is allowed to be positive, negative, or 0. Positive D, the list climbs. Negative D, like the ladder, it falls. 0D. The list just repeats the same number forever. And yes, that still counts as an AP. Formally, take any term and subtract the one before it, second minus first, third minus second, and you must get the same answer every time. That common answer is D. If the first term is A and the common difference is D, the whole list looks like this. A, then A plus D, then a plus 2D, then a plus 3D. This is called the general form of an AP, and notice the number in front of D is always one less than the term's position. One more distinction. If the list stops, like heights 147 up to 157, it's a finite AP and it has a last term, which we call L. If it runs on forever with those three dots, it's an infinite AP, with no last term. And to pin down an AP completely, one number isn't enough. You need both the first term A and the common difference D. Give me a equals 6 and D equals 3. I get 6, 9, 12, 15. Same A, but D equals -3, and now it's 6, 3, 0, -3. Different D, a completely different list. Now the reverse question, I hand you a list. Is it an AP? The test is simple. Subtract each term from the one after it. If you always get the same number, it's an AP, and that number is your D. For 6, 9, 12, 15, every gap is 3. So yes, AP with A equals 6, D equals 3. Critical detail, you always subtract the earlier term from the later one. Keep that order even when the list is going down. For 6, 3, 0, -3, 3 minus 6 is -3, not +3. The D is genuinely negative. Get the order wrong and you'll flip the sign and break everything after. Let's stress test it. 4, 10, 16, 22, gaps all 6, so it's an AP, and the next two terms are 28 and 34, but -2, 2, -2, 2. First gap +4, next gap -4. Not equal, so not an AP, and 1, 1, 1, 2, 2, 2, a gap of 1 sneaks in. Not an AP either. The rule is unforgiving. Every gap must match. Back to the salary. 8,000, 8,500, 9,000, and so on. Easy to find year 5. Just keep adding 500. But what about year 15? Year 25? Adding 524 times is painful. There has to be a shortcut. And there is. Watch the pattern build. The second term is a plus D. That's a plus 1D. The third term is a plus 2D. The fourth is a plus 3D. See it? To reach a term, you add D a number of times that's always one less than the term's position. So the nth term equals a plus, in brackets, n-1 times D. This is the single most useful formula in the chapter, the general term. Why n-1 and not n? Because the first term already is you've added D 0 times to get there. Every step after that adds one more D. And if the AP has a last term, that last term L is just this same formula with n equal to the total count of terms. Let's use it. The AP 2, 7, 12, find the 10th term. Here A is 2, D is 5, N is 10. Plug in 2 plus bracket 10 minus 1 times 5. That's 2 plus 45 equals 47. Done without listing 10 terms. Trickier in 21, 18, 15, where d is minus 3, which term equals minus 81? Now we know the term and we're solving for n. Minus 81 equals 21 plus bracket n minus 1 times minus 3. Work it through and n comes out to 35. So the 35th term is minus 81. And is any term exactly 0? Set the formula to 0, solve, and n equals 8. The 8th term is 0. The lesson. The formula links 4 quantities, a, d, n, and the term itself. So if you know any 3, you can find the 4th. Here's a 2-equation case. An AP's 3rd term is 5 and its 7th term is 9. Write each with the formula. A plus 2d equals 5 and a plus 6d equals 9. 2 equations, 2 unknowns, subtract them and 4d equals 4, so d is 1. Back substitute to get a equals 3. The AP is 3, 4, 5, 6, 7. Now a yes or no trap. Is 301 a term of 5, 11, 17, 23? Here a is 5, d is 6. Set the formula equal to 301 and solve for n. You get 50 point something. But n counts a position, so it must be a whole number. It isn't, so 301 is simply not in this list. Whenever n comes out fractional, the answer is not a term. 2 more, and these are the ones exams love. How many 2-digit numbers are divisible by 3? They run 12, 15, 18, all the way to 99. An AP with a 12, D3, last term 99. Set the formula equal to 99, solve for n, and you get 30. So there are 30 such numbers, counted without listing one. And a clever one, the 11th term from the last of 10, 7, 4 down to minus 62. The slick trick? Flip the list around. Read it backwards. And the new first term is minus 62 with a new common difference of plus 3. Now 11th from the end is just 11th from the start of the reversed list. Apply the formula. Minus 62 plus 10 times 3 equals minus 32. Reversing turns a hard from the end question into an ordinary one. Time to test yourself. Here's a question on screen. Pause if you need to, but try it in your head first. 10 seconds on the clock. Go. Use the nth term formula. Here a is 3, d is 4, n is 10. The 10th term is 3 plus, bracket, 10 minus 1 times 4. That's 3 plus 36, which is 39. That's option A. If you got it, you've genuinely understood the formula, not just memorized it. Let's lock it in. An AP is a list with one fixed common difference d. Its general form is a plus d, a plus 2d, and onward. And any term you want is a plus bracket n minus 1 times d. 3 ideas, enormous power. Before you go, one more question is on the screen. Don't say it out loud. Type your answer in the comments and I'll pin the correct one. Let's see who's paying attention. In the next video, we tackle the big one, adding up an entire AP in a single line, using a trick a 10-year-old named Gauss discovered. Subscribe so it lands in your feed. This is Clarix. See you there.